Hello friends, we are still not employed by a FAANG company, so let's not stop till we get there. Today we are going to work on a Leetcode Medium problem. Find the minimum value in a rotated sorted array. And let's understand the problem statement. We are given an array of length n where all the elements are sorted in an ascending order, but they are rotated somewhere between 1 to n times. So let's see what the statement is trying to say. Suppose we are given an array like this: 1, 2, 3, and 4. Now this is a perfectly good sorted array, and all the values are in ascending order. Suppose if we take the last element and we move it to the first position and then move all the other consecutive positions to the next, we can see an array like this: 4, 1, 2, 3. Now this is also sorted array, but the thing is it has been rotated once. So the value has been rotated once. If we were to rotate it again, we would find some value like this. So 3, 4, 1, 2, because we rotated 3 to the first position. Okay, now that we understand that what a rotated array is, let's try to see that how can we approach this problem and how can we find the minimum value in the given rotated array. So one approach is pretty simple. If we are given something like this, we just simply iterate over the array once and we would find the minimum value as 1. But the thing is, we are explicitly said in the given problem that we need to find the solution in log n time and not in a linear time. And this solution would give us in a linear time, so it won't work. So let's try to find the solution in logarithmic time. Let's see what are the potential cases we could have. Suppose we are given an array like this, and the left pointer is over here, the right pointer is over here, and if we see the middle pointer is over here. So now let's try to understand that what could be the approach we have. We would start our solution by comparing the left and right pointer, and if at any case if we find out that left pointer is actually less than right pointer, the value at left pointer is less than right pointer, this will only happen in the case when the array is rotated 0 times or n times. This is what I'm trying to say, that if our input array is like this: 1, 2, 3, 4, if we are comparing these four values, we can simply say that our left is completely less than right. But if this were array was to be rotated at for any number of times, ever encounter this condition, because say if this array has been rotated twice, the values would be 3, 4, 1, 2, and in this case left will always be greater than right. So this is what we will do for the we will do for in the first check. We would check whether for the given input array, do we satisfy that condition at any point in time, and if we do, we would try to find the minimum value and store it in the result. So at the same time, when we are running this algorithm, we would keep track of the result variable, and in the result variable we would be storing that what is the minimum possible value we have found so far. So at the end of, and the idea is at the end of our solution, we should have the minimum value stored in this parameter. So now initially we have given the scenario like this, and we would check that whether L is less than or right, which is not the case in this scenario. So let's move on to the next condition that can come in. Now we would compare the left value with the middle value, and we would calculate the middle value by doing the summation of left plus right divided by 2. Now, when we compare the left value with middle value, we could have two possibilities. Either left value is less than or equal to middle value, or left value is greater than middle value. So let's see what would be the approach for each of those conditions. If our left value is less than or equal to middle value, which is the scenario right here, that our left is 3 and our middle value is 5. In this kind of scenario, we would always know that the minimum value that we are trying to find out would be on the right side of the subtree and not on the left side of subtree, because on the left side of subtree, all the elements are going to be greater than whatever value of left we have, and they will continuously be increasing till we get to a point that was the original initial point of the actual input array, which was not rotated at all. And so if we look it over here, it becomes pretty evident that left is 3 and middle point is 5, and we know that the all the elements that are on the right side of middle have the potential to be of lesser value, because we are rotating the array and the original small values would be on the right side of the subtree. So whenever we encounter a scenario where left is less than or equal to middle pointer, we know that we need to update our left pointer. So whenever we encounter this condition, that if left is less than or equal to middle pointer, we would need to update the left side subtree to check on the right portion of the remaining array, and we would eliminate the left elements for the given problem. So the what would be our condition? Our condition would be, if we find out that left is less than or equal to midpoint, we would set the value of left to be mid plus 1, and we would continue with the loop. Else we would update, else if this is not the case and we find out that middle point is actually greater than, middle point is actually less than left. So suppose we have an example like this, something like this, and we find out that this is our left point, this is our right point, and this is our middle point. So first of all we check that whether, this array is already sorted or not, and in order to check that, we check that if left is less than right, which is not the case here, so we can ignore this condition and we can move on to the next one. So now we would compare left with the middle pointer, and if we compare left with the middle pointer, we see that the value of left is 5 and the value of middle pointer is 2, which means that left less than or equal to middle is not true in this case, and we can determine that the answer for this problem, the minimum value, does not exist on the right side of the subtree. It actually exists on the left side of subtree, because this condition is false and because the middle value, the left value is actually greater than the middle value. So we need to check on the right, on the left subtree, and we need to eliminate the values on the right side. So in this scenario, we would need to update the right side pointer, right side of pointer. And this is exactly what we are going to do in our else condition. Left is less than or equal to mid, we update the left side pointer to check on the remaining right side of the subtree. But if that is not the case, we update the right side pointer to check on the left subtree. So we do right side pointer to be midpoint minus 1, and then we continue with the loop. And in any binary search, the basic condition that we are going to play around with is actually going to be while left is less than or equal to right. And now let's try to run the algorithm that I am suggesting over here with the actual values and see that how can we, what answer can we find. Okay, so first of all, we would check that whether left is less than right, which is not the case. So we move on to comparing the left with the middle pointer. And when before we compare the left with the middle pointer, we are going to see that whether the value of result is actually less than the middle pointer or not. So in this case, the middle value is 5. So we would update the result with 5. And now we will check that whether the left is less than or equal to m, and which is the case, and which is the case here. So we can say that we need to check on the right side of the subtree. So we can remove these three elements, And now for the next iteration, our left would become this, our right would become this, and our middle pointer would become this. So again, we check. And now in the next iteration, we would first check that what is the middle value and compare it with whatever value we have in our result. So the value in our result is actually 5 and the middle value is 1. So we would update the value of the result and we would see that what is the condition that we can apply over here. So condition we can apply over here is if left L is less than or equal to middle pointer, which is still the case. And in this scenario, we need to update the value of left pointer to middle plus 1. And if we update the value of left to mid plus 1, we actually reach the value of right. And in the binary search, originally we started with a condition that we only need to run the loop while left is less than or equal to right, and we would have met this condition. So we would come outside of the loop, and when we come outside of the loop, we just need to return the value of result, whatever we have stored over here, and this would be the minimum value we could find in this given rotated sorted array. So let's move towards coding now.
We will start by creating two pointers, left and right. We will initialize left pointer to 0 and we will initialize the right pointer to the length of a given input array, -1. And we would create a variable to store the minimum value. Just name it min. And we will initialize it with the first element in the given input array. Let's create our loop for binary search. First, we will check that whether the input array is already sorted or not. If this is the case, we would update our result value and try to see if we find the minimum element. Now let's calculate our mid pointer and start the binary search. And now we will check our minimum value again. And now we will put the condition to update the left pointer or right pointer. If left is less than mid, we know the solution could be on the right side, so we update the value of left. Else we update the value of right. And once the traversal is complete, we simply return the minimum value. Let's try to run this code. Looks like the code is working. Let's try to submit it. And we can see our solution is pretty efficient. Let's see if we can do something else to make it more efficient. Thank you for watching. Please mention in the comments if you want me to update anything in the video and also suggest the next problems we can work on. Thank you.